Today, we're diving into the pretty dramatic story of a drug that was, for a time, a huge deal in the fight against a really tough virus. It's a story about brilliant science, a hidden danger, and how fast medicine is always moving forward. This is the rise and fall of Adefovir.
So just imagine for a second. You've got this powerful new weapon against a chronic disease, a total game changer. But what if that weapon had a secret risk, a flaw that could turn it against the very people it's supposed to save? Well, that's the central question at the heart of Adefovir's story.
All right, first things first. To really understand our hero drug, we have to understand the villain it was designed to fight.
So back in the early 2000s, the hepatitis B virus, or HBV, was a really formidable opponent, a huge public health problem. Doctors and patients were desperate for better options. And then, right on cue, this new drug shows up, Adefovir. And it wasn't just another pill. It was a major step forward, a new ray of hope against the virus.
So how did this new drug actually work? Well, its strategy was incredibly clever. You can think of it like a Trojan horse being sent deep into enemy territory. Adefovir's attack plan is basically a three-step process. First, you take it as an inactive pill. It's essentially a sleeper agent. Then, once it gets to the liver cells where the virus is doing its thing, it gets activated. It becomes a weapon. And here's the really brilliant part. The virus, which is trying to copy itself like crazy, mistakes this activated drug for one of its own building blocks and pulls it right into its own genetic code. It's pure sabotage.
And that's the knockout punch. Once Adefovir is inside the virus's DNA, it's like a broken zipper tooth. You just can't add any more pieces after it. The whole assembly line for making new viruses just grinds to a halt. The official term for this is DNA chain termination, and that was Adefovir's superpower.
But, as we kind of hinted at earlier, this hero had a secret. Its incredible power came with a really serious vulnerability. Yep, for all its cleverness, there was a dark side, a really significant trade-off that meant doctors and patients had to be very, very careful. The side effects were no joke. I mean, you had things like headaches and weakness, sure. But the main problem, the drug's Achilles heel, was nephrotoxicity, which is just a fancy way of saying kidney damage. And this wasn't a minor issue. It was the one thing that limited how it could be used and required constant monitoring. When you add in those other rare but serious risks, the picture starts to get a lot more complicated. And this wasn't some warning buried in the fine print. The risk was so real that the US FDA put a black box warning right on the label. That's the most serious warning they issue. It's basically a giant red flag to doctors saying, hey, be careful, the dose here is absolutely critical.
And this chart really shows you how narrow that margin for safety was. The dose that worked for hepatitis B was 10 milligrams. But when scientists tested higher doses, like 60 milligrams, which they looked at for HIV, they found an unacceptable risk of severe kidney damage. The line between being helpful and being harmful was just razor thin.
But the drug's side effects weren't the only storm cloud on the horizon. The virus itself, this formidable opponent, wasn't just going to lie down and give up.
You have to remember, viruses are absolute survival machines. And after being exposed to Adefovir for a long time, the hepatitis B virus did what it does best. It adapted. It started to evolve, finding little workarounds and learning how to spot the Trojan horse and keep it out.
And this wasn't just random chance. Specific genetic typos, or mutations, you see them there with names like nt/N236T, started to pop up in patients. These mutations were basically the virus's escape plan, changing its own machinery just enough so that Adefovir couldn't trick it anymore. The drug started to become less effective.
So now Adefovir is facing two huge problems. It's got a dangerous side effect, and the virus is learning how to resist it. The stage was perfectly set for a successor. Science had to go and build a better weapon.
And they did. The next generation of drugs came along, led by a drug called tenofovir. And it was just better than Adefovir on every single level. It was more powerful, the virus had a much harder time developing resistance to it, and, this is the big one, it had a much better safety profile, especially when it came to the kidneys.
And that was really the end of an era. With safer and more powerful options on the table, Adefovir was knocked from being a frontline hero to being a backup player, a second or third choice. Its role today is pretty much historical, a really important stepping stone for sure, but a stepping stone we've since passed.
So the story of Adefovir is really more than just the biography of a single drug. It's a perfect case study of this cycle we see in medicine all the time.
We find a new weapon, the target evolves to get around it, and so we're forced to innovate again. It leaves us with this really important question. In this constant race between our best science and viral evolution, how do we stay one step ahead?